In this lecture, we'll be taking a look at when to use views in MS SQL Server and when not to use views in MS SQL Server. Now, the first case that we'll be taking up is when to use views in our MS SQL database. The first thing is whenever you want to simplify complex queries. So views can be used to simplify complex queries by breaking them down into smaller, more manageable parts. For example, if you have a query that joins several tables together, you can create a view that encapsulates the join logic, making it easier to write queries against that data. Then, for data security, views can be used to restrict access to sensitive data by providing a simplified interface to the underlying data. For example, you can create a new view that only exposes certain columns or rows to specific users or groups. And then for performance, views can be used to improve performance by reducing the amount of redundant code in queries. For example, if you have a query that joins several tables together and includes multiple aggregate functions, you can create a view that encapsulates that logic, allowing you to reuse it across multiple queries without duplicating code. Now let's go ahead and explore some examples of the same. Now here, suppose you have a database that stores information about products, customers, and orders. You need to write a query to find all customers who have purchased a particular product. Here's how you can use a view to simplify the query. You can create a view. The first thing that you do is use the create statement, then specify the type of object that you're creating. Over here we're creating a view, so we're calling it view, and then you give a name to that view. Usually we prefix it with VW, and just to identify it as a view later down the line. So we are saying create view, view product sales as, and then we are selecting customer ID, product ID, order date, orders, join, order details on, orders ID, and then the order details dot order ID. Now you can write a simple query that uses the view to find all customers who have purchased a particular product. And to do that, you can just write over here, select distinct customer ID from view product sales, where product ID is 1234. So in this example, the view that you have created encapsulates the join logic between the orders and order details table, making it easier to write queries against that data. Now let's take up another example. Suppose you have a database that stores information about employees, departments, and salaries, and you need to write a query to find the average salary for each department. Here's how you can use a view to simplify the query. Select department ID using the aggregate function, average salary as average salary from employees grouped by department ID. Now you can write a simple query that uses the view to find the average salary for each department. We can simply go and say select all from view department salary. So in this example, you can see that the view encapsulates the aggregate function average used to calculate the average salary for each department, making it easier to reuse that logic across multiple queries. Now let's go ahead and explore when not to use views. We should be avoiding creating views when there is a complex logic that can negatively impact the query performance. Views that include subqueries or aggregate functions can be particularly problematic. In these cases, it may be better to use stored procedures or functions instead. Performance issues. Views can negatively impact performance if they are not properly optimized. For example, views that join multiple tables can cause performance issues if the underlying tables are large or poorly indexed. In these cases, it may be better to use indexed views or materialized views. Data modification. Views that are used for data modification, that is inserting, updating, or deleting data, can be problematic because they can introduce inconsistencies and make it difficult to maintain data integrity. In these cases, it may be better to use stored procedures or functions instead. Let's better understand all these scenarios by some examples. So the first example, when not to use views, is suppose you have a database that stores information about sales transactions, which includes salesperson, product, and date, and you need to write a query to find the total sales for each salesperson grouped by month. Here's why you should not use a view for this. Let's say you're creating a view which says sales by month, and you're selecting the salesperson ID, product ID, month, and amount as total sales from sales table grouped by salesperson ID, product ID, and month. Now you can write a query that uses the view to find the total sales for each salesperson grouped by month in this way. Select salesperson ID, month, sum of total sales as total sales from this view grouped by salesperson ID and month. Now in this example, using a view with complex logic can negatively impact query performance, especially if the underlying tables are large or poorly indexed. It's better to use a stored procedure or function that is optimized for this type of query. Now if we take a look at the other example, let's say you have a database that stores information about employees and departments, and you need to write a query to find the number of employees in each department who have been with the company for more than 5 years. Here's why you should not use a view for this. So you're creating a view, you're selecting the department ID count as employee count from employees grouped by department ID. Now you can write a query that uses the view to find the number of employees in each department who have been with the company for more than 5 years in this way. That is, selecting the department ID count as employee count from employees where date difference in terms of year using the hire date and get date is greater than or equal to 5 grouped by department ID. Now in this example, using a view that only counts the number of employees by department does not account for the additional condition of employees who have been with the company for more than 5 years. It's better to write a query that includes all the necessary conditions. Similarly, if we take another look when not to use views, is that let's say we have a database that stores information about inventory levels for different products. You need to write a query to update the inventory level for a particular product. Here's why you should not use a view for this. Let's say you're creating a view called product inventory. You're selecting product ID and inventory level from products. Now you can write a query to update the inventory level for a particular product. And here you're saying update this view and set the inventory level to 100 where the product ID is 1, 2, 3, 4. Now in this example, using a view for data modification can introduce inconsistencies and make it difficult to maintain data integrity. It's better to use a stored procedure or function that is specifically designed for updating inventory levels. To conclude, views can be a powerful tool for simplifying complex queries and improving performance, but they should be used judiciously and with care to avoid introducing performance and maintenance issues.